Hello, one and all. This is Sarvesh, lecturer in civil engineering, Government Polytechnic, Station Kanpur. The course is reinforced concrete structure, and we are going to discuss about the design of columns by limit-state method. The main objective of the present lecture is after completion of this lecture, you are able to know what is meant by effective length of a column, how to determine this effective length of the column, how it will affect on the strength of the column, right? And next, now we are going to discuss about the codal provisions, that is IS 256-2000 codal provisions for a design of axially loaded column. That means you need to follow the design codal provisions while designing the axially loaded column by limit-state method as per IS 456-2000. Then we will discuss about the how to determine the load carrying capacity of a short column subjected to axial load. Right? And before going to enter into the main topic, let us just recap what we were discussing last class. In last class, we were discussed about what is mean by column and pedestal, where it can be call it as column or where it can be called it as pedestal. That means if the length to least lateral dimension is greater than 3, then we can call it as column. If it is less than 3, then we can call it as pedestal. Right? Then we have discussed about how the columns are classified based upon their shape, based upon the slenderness ratio, based upon the type of lateral tiles provided, and based upon the um, this what is that? One is based upon the type shape of the cross section, shape of the member, and another thing is based upon the slenderness ratio, based upon the type of the reinforcement, and based upon the what is called the L effective by sorry, what is called another type is four. We have discussed four types now. That is long column and short column. Sorry, that is axially loaded column or eccentrically loaded column, right? So what is meant by axially loaded column means the load is exactly coincide or passing through the along the centroidal axis of the column. If it is not passed through the along the centroidal axis of the column, then you can call it as eccentrically loaded column, right? So these four types we have discussed, and again in that there are some other classifications we have discussed in last class. Then we have discussed about the type of reinforcement to be provided in columns. Right? These things we have discussed in last class. Then coming to the today's topic, that is effective length. So what is meant by effective length? Effective length is nothing but the height of a column is defined as the height between the points of contraflexure of the buckled column. What is it mean actually? Right? I will annotate it for the clear understanding. Right? See, effective length is nothing but the distance between the point of contraflexures of the buckled column, and it depends upon the degree of end restraint of the member. Right? Generally, it can be defined as the distance between the points of zero movements. Point of contraflexure means at the point of contraflexure, the movement is zero. Suppose, let us say, if you take a column like this. So this is a column, assuming that the both ends are fixed, because the effective length of the column depends upon the end conditions or end restraints. So let us assume here the both ends are fixed. For example, just I would like to show what is meant by point of contact vector. So here, due to the application of load, so this column will buckle like right, not exactly, but the similar way it will buckle. Let us try once again. Uh, it will buckle due to the compression load. It will buckle like right. So therefore, the point of contraflexure means where the moment is zero. So here, at here to here, this is called as your effective length. This is depends upon the end contraction. This will call it as L effective, right? So because the actual length is from here to here, this is called your actual length of the column or actual height of the column, but the effective length is nothing but the distance between the two contraflexure points or where the moment is zero, the distance between the points where the moment is zero, right? So it is depends upon the support condition, that is end restraint. So this will affect while calculate affect the strength of the column, right? Because it is a main factor in determining the strength of the columns, right? Even it is depends on the slenderness ratio also, because based upon this you have to decide whether it is a long column or short column. The design of long column and short column is completely different, right? So before going to start, you need to classify whether it is a long column or short column, right? So how to classify we are already discussed in last class, right? So this is called as effective length, and we will see for different end conditions how to determine what is the uh, effective length of the columns and how it will reflect. So I already yeah, see. For case one, that means uh, effective length effectively held in position and restrained against rotation at both the ends. That means the both ends are held in position and restrained against rotation. That means both ends are fixed. Whatever just I have shown. Just see here how the column has been buckled. See, same as just I have drawn it, right? So up to here it is exactly straight, then it will reflect like so, not like this, like this. So the effective length is from here to approximately, right? So how to determine as per Coral provision, the effective length is given as uh, 0.65 times an effect on unsupported length. Unsupported length is nothing but your overall length of the column. Therefore, the effective length is why? Because the effective length is decreasing, right? So here the effective length as per IS 456,000 is 0.65 L, right? So based upon this support condition, you have to calculate the effective length, and this effective length to be used in calculation of your strength, right? And next case is case 2. That is the supports are effectively held in position at both ends, but not restrained against rotation. That means both ends. So that means it is both ends are hinged, right? So effectively held in position at both ends, but not restrained against rotation. That means here rotation is allowing, but the changing the position of the support is not changed, right? So that is both ends are hinged. So in this case, the buckling shape is like this. This is the buckling shape end to end. So therefore, if you observe, the effective length is equal to the unsupported length. That is, effective length equal to unsupported length. That is, L effective is equal to L in case 2. That means both ends are hinged. Now coming to the case 3, that is effectively held in position at both ends, restrained against rotation at one end. That means one end is fixed, other end is uh, fixed and other end is uh, free. I cannot say it is free, uh, hinged. One end fixed and other end is hinged. In this case, it is not free, it is hinged because restrained against rotation at one end. Both ends are held in position. That means one end is hinged, other end is fixed. So in this case, the effective length is 0.8 times the unsupported length. That is, L effective is equal to 0.8 L. All these values are given in IS 456 2000, right? We'll see. I will show the table which is given in IS 456 2000, right? So this is the case where the one end is fixed, the other end is hinged. Therefore, the L effective is equal to 0.8. Next case is case 4, that is effectively held in position and restrained against rotation at one end. That means one end is fixed. At other end, not held in position nor restrained against rotation. You need to remember the terminology carefully because see, while designing a column, so or maybe while solving a problem, they will give the support condition like this. So you need to understand what is the support condition. Sometimes they will not give the directly whether it is a fixed or free or hinged support. So they will provide like this. That means effectively held in position and restrained against rotation. That means the position of the support is not changing and it is against to rotation. So it is not allowing to rotate it. That means the support is fixed. And the other end is not held in position, not restrained against rotation. That means it is free. If you observe in previous case, here you just see both held in position, right? That means both are in hinge, restrained against rotation at one end. That means one end is hinge and it is restrained against rotation. That means this will become as a fixed, and one end is hinge, right? So here the one end is fixed, the other end is free. So in this case, the effective it is a buckling state, right? And due to the applied load, then the effective length becomes as L is equal to L effective, that is 2 times of unsupported length. That is L effective equal to 2 into L. One end fixed, other end is free. One end is fixed and other end is free. The effective length equal to 2 times of the unsupported. So based upon the support conditions, you have to calculate the effective length of the curve. Right? So this is a table which is given in IS 456-2000, table number 28, right? And if you observe, there are two types of values here. The effective length of the compression member. There are two values, theoretical value of effective length, right? This is theoretical value of effective length and recommended value of effective length. What is the difference between these? Right? Just I will give a glance what is the difference between these two. These are the theoretical values, right? Determined it. And these are the recommended values. Why? Because we are assuming that the both ends are fixed, right? But there are some other conditions which will affect the effective length of the member. Fixed means it is very difficult to maintain the supports as rigid, because there are some criteria which will affect that we cannot fix the supports exactly fixed, right? It is very difficult to, and hinged is also same thing. We cannot give the hinge support exactly, right? So that is why there is a small difference between the theoretical support as well as recommended value, right? So generally, as per the theoretical value, it is different as compared to recommended value. So let me see what are the different values proposed by IS 456,000. So for first case, here some cases are given extra, that we will see. First one is effectively held in position and restrained against rotation in both the ends. That means both ends are fixed. So in this case, the effective length theoretical value is 0.5 L, right? But recommended value is 0.65 L. That is we have already seen, right? So I told this recommended value 0.65 L when both ends are fixed. And here the effectively held in position at both ends, that means both ends are hinged, restrained against rotation at one end. So that means one end is fixed, other end is hinged. So this end is fixed, this end is hinged. So in this case, what I told is the recommended value is 0.8 L, and for theoretical value is 0.7 L, right? And another case is effectively held in position at both ends. So both ends are hinged, but not restrained against rotation. That means both ends are hinged. In this case, both the values recommended and theoretically is 1 L if both the supports are hinged, right? Next is effectively held in position and restrained against rotation at one end. Effectively held in position, restrained rotation at one end. That means end is fixed. At other end, restrained against rotation but not held in position. Restrained against rotation, that means you can rotate it but not held in position. That means the position of the joint is allowed to change. So in this case, the theoretical value is L is equal to L and the recommended value is 1 point. Similarly, effectively held in position and restrained against rotation in one end, that means one end is fixed, and at the other partially restrained against rotation but not held in position. This is partially restrained against rotation but not held in position. So in this case, nothing is determined by theoretical value, but as per the recommended value is 1.5 L. And for effectively held in position at one end but not restrained against rotation, that means this support will become as hinge, and at other end restrained against rotation but not held in position. Restrained against rotation but not held in position, right? So in this case, the L will become as theoretical value is 2L as well as for um, recommended value is also 2L. Next is effectively held in position and restrained against rotation at one end but not held in position nor restrained against rotation at the other end. That means one end is fixed, other end is free. So in this case, effective length is 2L as a theoretical, and recommended value also is 2 times of L. So the small here the small L is nothing but unsupported length of a compression member. Column is a compression member. Right? So these are the different effective lengths to be considered as per the support condition. Right? So while designing or calculating the strength of the member, we need to take care of this effectiveness, right? So next is the codal provisions are requirements in design of columns. That is, first one is the minimum eccentricity. So yesterday I given a glance on the minimum eccentricity, right? And another one is recommendations on longitudinal reinforcement and transverse reinforcement, right? So what is meant by longitudinal reinforcement and transverse reinforcement? What are the codal provisions we need to follow while providing this reinforcement? So first one, we'll see the minimum eccentricity. As per the codal provisions, the compression member shall be designed for minimum eccentricity. That means whatever the member you are going to design, that should be allow the minimum eccentricity as per class number 25.4 of IS 456-2000. The minimum eccentricity should be calculated as per the codal provision, that is E minimum is equal to L by 500 plus D or B by 30, where D or B is nothing but the least lateral dimensions of the member which is going to be considered, right? And subjected to a minimum of 20 mm, right? Whichever is greater, right? So this you should remember. So while discussing in last class, there is that is the classification of columns. The one classification is based upon the eccentricity. That means axially loaded column and eccentrically loaded column. Right? Axially loaded column means the load is exactly passing the centroidal axis of along the centroidal axis of the column. That means this. Suppose this is your column, and the load is exactly passing through the centroid of this along this line. So this is the centroidal axis. The load is exactly passing through the centroidal axis. That means there is no eccentricity. Suppose if the load is, suppose this is your centroidal axis of the column, for example, and the load is acting at somewhere else here. That means there is an eccentricity with respect to this. This is called as E. So in constructing the RCC structures, exactly it is a little bit difficult, right? Because whatever we will do in computers is very difficult to execute because there are some other factors which will affect in construction, right? So as per IS 456-2000, it is allowing up to a minimum eccentricity, right? That minimum eccentricity should be calculated by this formula, that is E minimum equal to L by 500 plus D or B by 30, or subjected to a minimum 20 mm. That means the maximum we will allow the minimum eccentricity is 20 mm, or whichever is greater, right? E minimum should be less than or equal to 0.05 D. Then only the column should be designed as a axially loaded column. If E minimum is exceeds 0.05 0.05D, then that column should be designed as a long column. As I explained earlier, if it is a axially loaded column, the stress is completely depends upon only the load. If it is a biaxial or uniaxial column, eccentrically column, that means due to the eccentricity, it will develop a extra moment in the member, right? So you, while designing, you need to take care about that moment also. That is E into this flow. That is called as moment. And this moment is depends upon the eccentricity, the distance from the axis. And again, there are two eccentricities. That means whether it is with respect to one axis or with respect to two axes. That means uniaxial, axial, uniaxially eccentrically column, biaxial eccentrically column. That means whether it is a one with respect to one axis or with respect to both the axes. Just I will show it for clear understanding. Right. So you see here you see here the eccentricity, it is the centroid of the column, right? And the eccentricity with respect to this axis is, this one, this axis. And with respect to this axis is this, right? So this will happen generally, suppose if you have a rectangular square column, then you have a centroidal axis. And if you see from top, if the load is here, let us say, if the load is acting here, therefore, this load is eccentrical with respect to this axis and with respect to this axis. This is called as biaxially loaded column, right? So in this case, you have to take care about the bending moment with respect to this axis as well as with respect to this axis. That is mx and my will come into picture. And therefore, the design of this column is different than the axially loaded column. So while designing, you need to check whether it is a eccentrically loaded column or axially loaded column, right? So in axially loaded column, as per IS 456,000, we can allow only up to a maximum of 20 mm SME, right? If it is exceed, then you have to design as a eccentrically loaded column, right? And next criteria is the longitudinal reinforcement. That means whatever the reinforcement you are providing, so as I told earlier, there are two types of reinforcement, lateral reinforcement and longitudinal reinforcement. Suppose this is your column and you have to provide a, if you see in the plan, and this is your reinforcement, right? So these are called as, your longitudinal reinforcement or compression reinforcement. This is called as lateral type, right? So this longitudinal reinforcement, as per the codal provisions, the longitudinal reinforcement should not be less than 0.8% of gross cross-sectional area of the column. That means it is nothing but your minimum reinforcement, right? So the minimum reinforcement, the longitudinal reinforcement, should not be less than 0.8% of gross cross-sectional area of the column. Suppose this is your A, and if it is a square column, let us say this is also A, right? So the area is A into A square, A into A square. So the minimum reinforcement, longitudinal reinforcement should not be less than 0.8% of A square, right? And the maximum reinforcement, these criteria and guidelines are given in your IS 456,000 class number 26.5.3. that is longitudinal reinforcement. So you should go through the IS code book. It is officially allowed in the examination also. So, so you can read from the code book, right? So the minimum reinforcement is 0.8% of A square, and the maximum reinforcement, that means the reinforcement of lateral longitudinal reinforcement, should not be greater than 6% of gross cross-section area of the part. That is the maximum reinforcement. But there are other limitations as per IS 450-6000. You just go to the code book, clause number 26.1.3, point 1, longitudinal reinforcement. The cross-sectional area of longitudinal reinforcement shall be not less than 0.8% nor more than 6% of the cross-section area of the car, right? But there is a note. This is very important note. While designing, you should remember this one. The use of 6% reinforcement may involve practical difficulties in placing and compacting the concrete. Hence, lower percentage is recommended where bars from the column below have to be lapped with those in the column under consideration. The percentage of steel shall usually not exceed 4%. Right? Let me explain what is steel. Obviously, the IS 450-6000 is recommending that the maximum percentage of longitudinal reinforcement in column should not be greater than 6%. But generally, there are some practical problems because if you provide 6% of cross-section area, the cross-section area as a your longitudinal reinforcement, so it is very difficult to is given what the practical difficulties in placing and compacting the concrete because the huge reinforcement is present, so it is very difficult to maintain a proper cover and pouring the concrete and compacting the concrete because you need to put the vibrator for compaction purpose. So the diameter of the vibrator may not be allowed if you provide more reinforcement because the gap will become very less, right? So due to the practical point of view, the maximum reinforcement, longitudinal reinforcement should not be reinforcement is limited to 0.4%, sorry, 4% of gross cross section area of the part, right? So the IS 456 2000 given maximum percentage is 6%, but you should limit your maximum percentage of longitudinal reinforcement at 4% by considering the practical point of view, right? So these are the guidelines which are provided by the IS 456-2000 for designing the axially loaded column, right? This is related to longitudinal reinforcement. Then coming to the minimum number of bars, this is very important, right? The on diameter to be provided. This is also given in the same clause, that is 26.5.3.1. The point number yeah, point number 3, sorry, point number C. The third point, that is point number C. That is the minimum number of longitudinal bars provided in a column shall be 4 in rectangular column and 6 in circular column. See, I am reading from the code book directly. It is already given. It is officially allowed for your end examination also. You just familiar with your code book because a lot of information available in your code book. While designing a member, you need to follow the guidelines which are provided in IS 450-6000 according to your type of the member and design, right? So here the maximum number, the minimum number of bars per square and rectangular is 4 numbers, and for circular it should be minimum 6 numbers. It's very important. The competitive examination, what are the minimum number of bars required for circular column? That is 6 numbers is required. And the minimum diameters, it is given in the next point. The bar shall not be less than 12 mm in diameter. The minimum diameter of the longitudinal bars is 12 mm. And the maximum permitted spacing along the periphery of the column is 300 mm. That means, suppose if this is a column, let us say, and you have the reinforcement. I'm not drawing the lateral ties. So let us say there are some. Let us say anything have some. So the maximum spacing along the periphery of the column is 300. That means the distance between these columns or these distance should not be greater than 300 mm. Right? So while designing, you need to follow these guidelines. You need to remember these guidelines, right? You need to follow it. So this is about the longitudinal reinforcement. Next, coming to the minimum number of bars and diameters are to be provided. This is for nominal cover for longitudinal reinforcement bars. That is, nominal cover is 40 mm or diameter of larger bar, whichever is more. The minimum cover you should provide is that is cover, clear cover, whatever we have discussed. That is 40 mm or diameter of the bar, whichever is greater, that should be provided as a cover for longitudinal bars. And the column size, minimum column size is 200 mm or less, and when main bar diameter is not exceeding 12 mm, cover and 25 mm. What does it mean? So that means it is given in your IS 456-2000 same class. The column size 200 or less, the main bar diameter not exceeding 12 mm. If the column size is 200 or less, and the main diameter of the bar should not be exceeding 12 mm, and the cover is 25. Right? If the column size is less, very less, that means it is 200 or less, but the diameter of the bar should not exceed 12 mm, and the cover is minimum 25. That you need to follow. So these are the related to your longitude and reinforcement in columns. Next, coming to the lateral ties. Right. So lateral ties, the diameter of the lateral ties. The diameter of the lateral ties or circular rings or helical reinforcement shall not be less than 1/4 of the diameter of the largest longitudinal bar or 600 mm, whichever is less. That means the diameter of the lateral ties. Lateral ties means I have shown in last class, which is provided. So suppose this is your column and you have to connect all the bars. Suppose you have a one bar here, and another bar here, and you need to provide a ring by connecting all these bars. So this is called your lateral ties. Generally in beams we can call it as a stirrups. In columns we should call it as a lateral tie. We can provide in terms of a square, rectangle based upon the type of the column. Right? If you provide a circular column, then you need to provide a circular. So helical we'll discuss. We have already discussed in last class. Glance. Today we will discuss it. What is mean the helical and how to provide it. So come to the diameter of the lateral ties is 1/4 of the diameter of the largest longitudinal bar or 6 mm, whichever is less. That means we need to provide minimum 6 mm as a diameter of the lateral, right? And the pitch is nothing but what? It is the distance, center to center distance between the lateral ties. That means suppose this is your column, for example, and you have a this is, let us say, it is a longitudinal cross section, and you need to provide a ties like this, lateral ties, right? I'm not that much familiar with the drawing with this annotation because it is not exactly coming. So therefore, the distance between the center to center distance between these two, any two lateral ties is called as pitch, right? Then the pitch, lateral ties pitch should not be more than the least of the following, right? That is least lateral dimension. Next one is 16 times the diameter of the smallest longitudinal bar and 300 mm, whichever is less, that should be provided as your pitch. That means the pitch distance should be less, should be least of these following. One is least lateral dimension, whichever is least, that should be considered. Another one is 16 times the smallest longitudinal diameter of the bar, longitudinal bar, and 300 mm, whichever is least, that should be provided as your pitch, right? So this is about the lateral ties. Next, coming to the helical reinforcement. What is meant by helical reinforcement? In last class, we have discussed about the helical reinforcement. That means while classifying the column based upon the type of the lateral ties, it can be classified into a lateral ties, axially loaded column with lateral ties, axially loaded column with helical reinforcement. The main purpose of providing helical reinforcement is to increase the load carrying capacity of the column and increase the stiffness of the member. And remember, the helical reinforcement is possible to provide only in circular columns. It cannot be provided in rectangular or square columns, right? Uh, I think I have shown in last class helical reinforcement means in circular columns. If you see the cross section, suppose these are the longitudinal bars of a circular column, and these bars are joined by let us say I will take this one like along the line. So this is called as, just like, see, if you take a thread and just round it, that is called as your helical reinforcement. And for helical reinforcement, the diameter of the helical reinforcement should not be less than 1/4 of the diameter of the largest longitudinal bar or 600 mm, whichever is less. So the diameter of the helical bar, least of this one, 1/4 of the diameter of the largest longitudinal bar or 600 mm, whichever is less. So based upon that, you can decide the diameter of the helical reinforcement. Next is the pitch of helical reinforcement. And this helical reinforcement pitch should not be less than 25 mm or 3 times the diameter of the steel bar forming helix, and pitch shall not so what is this pitch of helical reinforcement. And so you should take the minimum of this, that is 25 mm or 3 times the diameter of the steel bar forming helix, nothing but this helical reinforcement. And pitch shall not be exceed 75 mm and 1/6 of the core diameter of the bar, whichever is less. So you just calculate all these 4 pitches, out of which you can provide the minimum. what is mean by core diameter? Core diameter is nothing but the center to center distance between the helical reinforcement. Suppose if this is your circular column plan, and these are some bars, and you are connecting this helical reinforcement. And if you see exactly, suppose this is your, just I would like to direct this one, and you have a minimum bars, just end of the drawing it, and you are connecting with the helical reinforcement. If you see, uh, yeah, so it has its own thickness. So if you see, the thickness may be like this. It is not coming clearly. I just right. The core diameter is nothing but the center to center distance between the helical reinforcement. This is called as your core diameter. You can call it as CC, right? So like this, you need to find out the pitch of the helical reinforcement. And what is meant by pitch? The center to center distance of this one. This is called as pitch distance, right? So right. So due to the time constraints, I'm just concluding the today's class. So just summarize what we were discussed till now. So we have discussed about the what is mean by effective length of the column and how to determine the effective length of the column. That means how it will affect the how the support conditions will affect the buckling pattern of the and what is the effective length of the member for different support conditions. So, and we have seen uh, the codal provisions for different cases. That means both ends are fixed, both ends are hinged, and both ends one end fixed, one end hinged, um, one end fixed, other end free, and different cases we have seen, and all these cases are given in IS 450 table number 28. So based upon that, you can calculate it. And we have seen what is the difference between the theoretical value as well as the recommended value. Then later, we have seen the codal provisions in design of the column. That means the eccentricity of the column. That means in eccentricity, the codal provision itself allowing a minimum eccentricity, whichever is greater. That is based upon the formula which is given, you can calculate the minimum, and that should not be greater than the 0.05 times of P. If it is exceeded, then the column should be designed as eccentrically loaded column. If it is less than this one, then you can design as a axially loaded column, right? And another codal provision is the longitudinal reinforcement. So the longitudinal reinforcement, minimum reinforcement should not be less than 0.8% of cross-section area of the column, and maximum is should not be greater than 6% of cross-section of the area of the column. But as per the practical point of view, because if you provide up to 6%, then it is a little bit difficult for placing and compacting concrete. So you should not, it can be 6% is limited to 4%, right? So while designing, you should remember these provisions. Then we have discussed the minimum number of bars should be used as a longitudinal bars. For a square and rectangle, minimum is 4 bars, and for circular, the minimum number of bars is 6. Then we have checked for the pitch of the lateral tiles and pitch of the helical reinforcement, how to decide. So these are the things we have discussed in this class. So next class we will discuss another topic. Right? Thank you. So I request you all to please go through the familiar with the code book, ISO